In this video, we are going to see RL transient response for step input. For that, we need a step function as the input. So that will be taken from a voltage source, signal voltage source. That we have the step input. That we will place it in the workspace. Now we will take the ground for the circuit. Now we will take next we will take the resistor. We will take a 1 kilo ohm resistor as a standard rated resistor. Then we will take the inductor value. Initially we will take a 1 millihenry. Then we will slowly change the values. Now connect all the components in series manner. Resistor, inductor, then we closed to the step input. Now connect the ground over. Now we will set the input values for the step input. Initial value we will set as 0 and the final value as 10. The start time is as 0. Okay, and now in the simulate tab we can set the analysis and simulation. So there we are going to see the transient analysis. So transient analysis, there we will take we have 4 options in the initial conditions. There you set to 0. The start time is 0 and end time is, let us take a 0.01. Now in the transient we will see the variables to see the transient. Let us take the current as the inductor current as the variable, as the first variable. Now everything is okay. Now let us run this diagram. We have the graph. When we run this diagram, we have the graph like this. So from this graph we will not get any proper information. So we will change the step time. We will change the step time in the simulation tab. And of course we will change the inductor value as 100 millihenry. Then once again we will see the graph is somewhat improved. Now also we will not get much information. Let us change the time. The time is changed in the simulate tab, analysis and simulate. There we change the time, slightly reduce the time. Let us see what will happen when we write. So here absolutely we didn't get information. We will not get any information from this. Now we change the time is slightly 0.01. It is a correct time. Slightly reduce the time. Now when we see run this diagram, we have the graph. So now this graph is somewhat improved. It is like looking like exponential graph. So there we have the cursor tab, show cursor. So in the yellow color we have the sliding point. So that sliding point can be moved anywhere. So as we know, the time constant for a RL circuit is L by R. L value is 100 millihenry and R value is 1 kilo ohm. When we calculate the time constant manually, that is 100 microseconds. So here also 100 microseconds. At that time we have the value 6.32. That is 63% of maximum value. So this is the graph for current values. The same thing can be done for the voltage across the inductor. So that there we can change the output palette. You can change this voltage and remove the current. Now save this and run the diagram. We have see the graph is exponential decaying graph. Now in here also when you see this yellow color sliding contact, we can move. That is 100. Here also we can see that is 6.38 as the 3.68. Sorry, 3.68 we have the time. So approximately we can get the time as 101. That is closely 100 microseconds. So this is the way we can calculate the transient response of the